Hello, my name is Maria Flores. This is my discrete math test number 2. Our agenda today is to first explain the problem, going to then explore it, and then I'm going to do some math to prove it, and then we're going to celebrate, because always got to celebrate the little things. So my question was question 2.12, and that was to show that the function p of k equals k plus negative 1 to the k times c is a permutation of the set of all integers whenever c is an integer. So what does that mean? Let me explain. First, let's talk about what a permutation is. So permutation is kind of like a method of finding the number of possible arrangements in a set when order matters. So we know that order is important, and it's basically just arranging things in different orders. So an example of this is if we just look at these 3 shapes and find all possible arrangements of them, that there's a permutation. So let's look at our goal for this problem. We're going to prove that the function results in a permutation when c is any possible number. So we need to prove that when c is any integer, that the permutation is going to contain every single possible integer as well, and that it's never going to be undefined. So you're never going to plug in any possible, there's not going to be a possible integer of c that's going to make the function undefined. Allegedly, that's what we're hoping. So let's just explore it a little. I plugged it into Excel and I went all the way to the 200s, but we're just gonna look at this snapshot of when c is 0 to 10 and when k is negative 10 to 10. So something that I observed is that when even values of c, so when c is an even number, it starts even. It's one of the first numbers is even. And then for odd, it starts with odd numbers. And they just kind of alternate like left and right as well. We also notice that numbers are in every value of c. So we have 1 is going to be in every value of c. And 5 is going to be in every value of c. So another thing that I've noticed is that in the textbook we are told that p of k equals k plus c. Like, apparently that's always true. And here we look at it when we see that when c is 2, let's say we do plus 2. When we look at that, p of k is 4. Let's try again with 8. So when k is 8 and c is 2, 8 plus 2 is 10. Whoa! No way. Isn't that crazy? That's just a fun little observation I made. So let's do some math to figure out what is going on. So we are given the function p of k equals k plus negative 1 to the k times c. And from what we know from the textbook, we know that p of k equals n and p of k equals k. So another way to think about this is k equals n. So we can just plug n into k. So we're just basically assuming that p of k equals n plus c. Fun. So ignoring all this, if p of k equals n, that means a function of k equals n. Let's assume, or let's try to figure out what a function of n equals to k is. That makes sense. We're basically finding the inverse is another way to think about this. So let's just try to find the inverse. So first let's just set n equal to the function of p of k that we're given. And so we have that. So we also know that p of k equals n plus c from what we assumed earlier. So if n plus c equals that function, then n plus c equals k plus 1 plus negative 1 to the k times c. And let's take a closer look at this little thing, this little gizmo right here. So when we set k to equal to an even number, like 2, -1 to an even power is going to be +1. So that means n plus c is going to be positive. I mean, not positive. Well, yeah, n plus c is going to be an even number. And if we make k odd, like 3, -1 to an odd power, like 3, is always just going to be -1. So it's going to be equal 0. So if you plug that into this equation here, n plus c is odd. So we know that k equals n plus c can be either even or odd. So let's just switch the k here to n plus c, since we know they're equal, and let us do some simplifying to get k equals n minus -1 to the n plus c times c. So we know, since k equals this function here, and we know that k equals g of n, that means g of n must be this function. So that is basically the inverse of the p of k equals n that we had there. So what does this mean? Well, let's take a look-see at it. Let's plug it in into Excel. So this is the inverse of the function, and we notice that um, these values are the same. The even values are the same from the function that we were originally given. And then the odd numbers kind of switch out, but we notice that it's easier to look at this graph than the other one because they're all just like diagonally aligned, kind of. Most of them are diagonally aligned. The odd numbers just kind of go in this nice diagonal, so you can easily see that every number is going to be in every value of c. It's going to go on forever and ever. It does not stop. And when we look at the even numbers, they just like decrease constantly as you go further up like that. So from this, from the inverse, we can tell that the permutation certainly does exist. And now, and celebrate. We figured it out. Everything is great. We're happy. It's been